Hi everyone, so this is tutorial sheet 4, question 8. So the question is, let the matrix M be equal to that, and then they are saying find the values of P for which the matrix M is singular. So we know to say if the matrix is singular, the determinant of that matrix is equal to 0. So in short, what they're trying to say is that the determinant of M is equal to 0. So in short, we're going to find the determinant in terms of P and then equate it to 0 and then solve the equation to find the values of P. So this is going to be like this: 3 outside, and then the minor for this 3, we're going to have 2P times P, which is 2P squared. We're going to have 2P squared, and then minus 2 times 1, you get your 2 like that. Then close brackets, you put your negative 1 there, and then you open brackets. You find the minor for that negative 1 to be 1 times P, you get your P, and then minus 0 times 1, you get your 0 like that. This 0 times 1, you get a 0. 1 times P is P. And then we move on to negative 3, this side. So what we're finding is the determinant. We said after finding the determinant, we're supposed to equate it to 0. And then, so we write the negative 3 there, we open the brackets. The minor for negative 3 will be 0 times 2P, which will be 72, sorry, so 72, that's the product, and then from there you're going to have your sum, sorry, the factors are going to be 8. The product here is supposed to be negative 72. So for you to get negative 72, you need to multiply 2 numbers, and those 2 numbers, when you add them, they are supposed to give you a negative 1. So I think these are 8 and negative 9. So we can put them there. 6P squared minus 9P, then plus 8P minus 12 being equal to 0. So now, having done this, we can now factorize. What is the common number here is 3P. 3P is common. Then 3P into 6P squared, it goes there 2 times. It goes there 2 times, like that. And then minus 3P into 9P, it goes there 3 times. And then here you're going to have your plus 4 into 8P, you get your 2P there. Then minus 3, close brackets, is equal to 0. Then from there you say 2P minus 3 in brackets like that, and then 3P plus 4 in brackets is equal to 0. So there I just equate all these factors to 0. So when you get 2P minus 3 to 0, you're going to get your value of P to be equal to 3 over 2. When you equate 3P plus 4 to 0, you're going to get your value of P is to be equal to negative 4 over 3. So these are the values of P that are going to make the matrix to be singular. So I've answered part A. Let us move on to part B. So part B is saying solve the equation M x, y, z equals to negative 7 over 2 in the case where P is equal to 2. And then they are also asking you to find the determinant. So in short, while there is P in this M, in this matrix we're going to put 2. So let's rewrite the matrix here. Oh, sorry. Okay. It's going to be like this. It's going to be 3, 1, negative 3. Then we're going to have 1. Here we're going to have 2p. There we're going to have 1. This is 0, 2. Then you're going to have p there. So while there is p, we have to put 2. So when you put 2 here, 2 times 2, we're going to get 4 there. Yeah, and then on p here, you are going to get, you're going to put 2. Alright, so this is our new matrix. So this is our new matrix. So now they are saying this same matrix M, let us write it here now. Instead of us writing it there, let me just move the same one that I've written here. So I'll move this one. They are saying this same matrix, when multiplied with x, y, and z, it gives those values. Let me put it here. Okay. Right. So they're saying when you multiply this same matrix with x, y, and z, x, y, and z, you are going to get these numbers. Negative 7 over 2. You're going to get positive 11 over 2 and 5 there. This is what we're going to get. So now this is a simultaneous equation. So if you want, you can simplify it and then start solving it, but the best way for you to do this using the matrix method is to first find the determinant of this, as the question says. So the determinant of this is equal to, so the determinant of this is going to be equal to 3, and then open brackets, 3 open brackets. Then actually what we can do here is just that I've rubbed that expression that I wrote in terms of p. Anyway, I can remember it. So what we can do here, we can do this instead of us wasting time to start writing the determinant and everything. It's better for us just to get that same equation. This same equation represents the determinant of this equation. It represents the determinant of this matrix. So where there is p, we are told to say, so I'm saying this is the determinant of m. So the determinant of m, we just need to replace where there is p with 2. So we're going to have 6, while there is p we put 2, then minus 2 minus 12. So let's simplify this. This is 4 times 6, that is 24. 24 minus 2, 24 minus 2 you get this is 4 times 6, you get 24, and then 24 minus 2, you get 22. 22 minus 12, you get 10 this side. So the determinant of that matrix is 10. So now, for us to solve this system of equation, we are going to use what is called Cramer's rule, where we replace the answers here on the part where we want to find the answer, the solution. So this first column here represents x, this second column represents y, and then the third column there represents z. So I'm going to start with x, finding x. So if I want to find the values of x, I'm going to replace my answers this side in the line of x there and find this determinant. So I'm going to say 7 over 2, I'll write it this side. This is negative 7 over 2, and then I have 11 over 2, and then there is a 5 there. And then apart from that, let me now just copy the remaining numbers, 4, and then we have a 2 there. This is negative 3, and then this is 1, and then this is 2, and then this is what I'm going to have. This is what I'm going to have as my first I'm finding dx. So let me find the determinant of the x component here. So the determinant there will be, first I will put my negative 7 over 2 there, and then open brackets, the minor there will be 4 times 2, 8, 8 minus 2, I'll get a 6, I'll put my 6 there, and then minus 1, and then open brackets, 11 over 2 times 2, I'll get 11, and then 5 times 1, I'll get 5, so I'll subtract 11 minus 5, I'm still getting a 6 there. Then lastly, I'll write my negative 3 that side, and then open brackets. So 11 over 2 times 2, I'm getting 11, then 5 times 4, I'm getting a 20. So 11 minus 20, I'm getting a negative number, which is a negative 9. Is it? Yeah. So this, when you simplify it, we're going to have our dx, the determinant in the x. Let me just move this side so that at least we have enough space. This is dx. So after finding dx, we're going to find our x to be, x is equal to the determinant of x over a determinant d. So our overall determinant d, we found it to be 10. Now let us find the dx which is supposed to be there. So the dx here is going to be 6 times 7 over 2 times 6, you get your answer to be negative 21. And then when you multiply this, you get negative 6. When you multiply that, you get your positive 27. So this will give you the answer to be, when you add them, you get your answer to be 0. So when you put your 0 there, then find your value of x. So meaning our x is nothing but equal to 0. So we move on to finding y. Let's find y. So y, we'll copy the same matrix there, but to change in the y column here, we're going to put the answers. So I'll write the same things here, 1 and then 0 there, and then in the y I'm putting my answers, which is negative 7 over 2, and then we have 11 over 2, and then we have 5. Then lastly, this side I'll rewrite everything the way they are, 1 and then 2. Then from there, it is now for us to find the determinant in the y column. So the determinant in the y column, I'll get this line down here because I know that it at least has a 0. So this row, when I multiply 0 times the first minor that I'm going to have, I'll still get a 0. So I'm moving direct to 5. This 5 is supposed to have a negative 5. And then open bracket, you find the minor for this 5. You find it to be 3 times 1. That is 3 minus 3. 1 times negative 3. You get your 3 plus 3, which is a 6 there. And then we move on to positive 2. And then open brackets, the minor for that is 3 times 11 over 2. You get your 33 over 2. And then minus 1 times 7 over negative 7 over 2 to be negative 7 over 2, which is just the same as plus 7 over 2 now. So when you find this, you add them. You are going to have, this is negative 30. And then here, I guess you are going to have something like 20. Yeah, it's going to give you 20 times 2, which gives 40. So you're going to have 40 there. And then when you add the 2, you are going to get your answer to be 10. So this is what you're going to have. So from there, we move on to finding the... So we move on to finding y now. So y is found by dividing dy over the general determinant. So our dy there is 10, divided by 10, you get your answer to be, so 10 divided by 10, you get your answer to be 1. So our y is equal to 1. So we proceed, we copy the same matrix we want to find the determinant of x. Copy the same matrix there, which is going to be 3, 1, 0. So in this time around, the answers will be put here on the z component. First, let us copy what is in the y. 1, 4, 2. So 1, 4, 2 is in the y. 1, then you have 4, then you have 2. And then you're going to have something like this. And then you're going to have 11 over 2 in the z there. And then lastly, you're going to have 5 there. So here what you're going to do again, since I know that there's a 0 here, so instead of me wasting time to start calculating a lot of numbers, I'm just going to get the row which has a 0. So the row which has a 0 is going to help me find my answers very, very quickly. So this is 0. So the first one there, I'll get a 0. 0 multiplied by the minor there, I'll still get a 0. So then second one, I'm going to get negative 2. Then multiplied by the minor of this negative 2 is going to be 3 times 11 over 2. Of course, I'm getting 33 over 2. And then minus 1 times that. 1 times negative 7 over 2, I'm getting a negative 7 over 2. Multiplied by that negative, you get a positive 7 over 2. And then plus, you write your 5 there. Then open bracket. And the minor for that will be 3 times 4, which is 12 minus 1. 12 minus 1, you get your 11 there. So you put them like that. So from there, so this is going to be your 20. When you add these two, you get 20. 20 times negative 2, you get your negative 40. Negative 40 plus 5 times 11, you get 55. So your final answer there is going to give you 15. So your dz has given you, the determinant in the z column has given you 15. So meaning to find z, we are going to write dz over d. So dz there will be 15, then divide by our d, we found it to be 10, which is there. So our d was 10, which is equal to, now when you divide this, you're going to have 3 over 2. So these are your answers. So meaning your final answers will be x is equal to 0, and then y is equal to 1, and then z is equal to 3 over 2. So these are going to be your answers. Let's proceed. Let's finish up the question. So there, the last question is saying, find the value of t for which the determinant of that is equal to 0. Let's see what we can do. So the determinant of that is going to be, first you write 1. You write your 1 there, sorry. Okay, you write your 1 there. Open brackets. So you're going to have t times t minus 1, which is going to give you t squared minus t. T squared minus t. And then apart from that, you also you are going to have minus 9 times 7. 9 times 7, you find your answer to be 63. Yeah, you have 63 there. So this is what you're going to have. And then apart from that, you are going to have 0 plus minus 0 so minus 0 multiplied by, so 0 multiplied by the minor that we're going to find for 0, still you get your 0. So it's better you just keep it and you skip it, you go to 3, the last number here. 3, so we're going to open our brackets. 5 times 9, you get your answer to be 45. And then 3 times t, you get minus 3t. So we're trying to find the determinant here. So this is t squared minus t minus 63. So this was minus. Again, there's a negative there. So meaning this is going to give us a plus. So plus 63. Then we go this side, 3 times 45, you are going to have plus 135. And then 3 times 3 there minus 9t, which gives you 0. They're saying the determinant of that is equal to 0, so this is supposed to give us 0. So just pair the like terms here. Negative t minus t, you get your 10t. So first I'll write the t squared there, and then this is going to give me negative 10t. So this is going to give me negative 10t, and then 63 plus 135, you get 198 as your answer. So positive 198, like that. So just remaining with solving the equation. So what you do there, if you see the numbers are too big to be solved, okay, let's try. And are there 2 numbers that we can multiply to give us 198? Then when we add them, they'll give us 10. I don't think they are there. Let's try to just find, to just calculate this using the formula method. So it's going to be t, which is equal to negative b plus or minus the root of b squared minus 4ac. Then everything divided by 2a. So this is how it's going to be. So negative b to be positive 10 now. So plus or minus the root of 10 squared will give you 100. Then minus 4ac, which is just the same as 4 times our a is 1, and then our c is 198. And everything divided by 2a. Our a is 1. 1 times 2, you just remain with 2 like that. So from there, you can write to say this is going to give us 10 plus or minus the square root of, so 198 times 4, your answer will be 792. So subtract 100 minus 792, you get your negative 692, like that. So we proceed. I'm going to have something like this, then over 2, like that. So this in complex form can also be written as 10 plus or minus, mind you, we're finding the value of t. So this is going to be 2 times 2 root 173. If I've not mistaken, you can try to test it, because what I mean is this root of negative 160 or negative 692 can also be written as 4 times 190, 4 times 173, not 190, something like that. So this, just this in brackets, in the under the side, can be written as this, and then when you separate this times negative that, when you separate this, you're going to have something like this. Then everything divided by 2, meaning it can also be simplified as 5 plus or minus the root of 173 I. So meaning the values of t are imaginary numbers, are complex numbers, which are t being equal to 5 plus the root of 173 I, and comma t is equal to 5 minus the root of 173i. So these are the answers that you can get. If I've not made any mistake in the calculations, then these are the final answers. Yeah. So thank you very much for watching. Make sure that you subscribe to the channel. Don't forget to subscribe to the channel so that you don't miss out on the videos that I'm going to be posting. So there are videos that I always post without posting them in the groups. So if you have not subscribed, you will be missing out such videos. Okay. Shalom.